Welcome to this professional development presentation on the equal sign. I can guess the main question that is currently going through your mind. And it's a great question. We all know that the answer for about 99% of you is probably because you were told to. But if you can bear with me for the duration of this presentation, I think you'll be pleasantly surprised and hopefully walk away with a different perspective to the one you started with. So what will today's session look like? Well, we're going to start by warming up your brain. Then we're going to look at and discuss the equal sign, students' misconceptions, and the impact these misconceptions have. We'll discuss how we can fix the problem, and at the end, there'll be a final task and a chance for further discussion with your colleagues. So let's start here. I'd like you to use the numbers and symbols listed here to create a number sentence. It can be for any grade, the one you currently teach, or one of your choosing. Imagine it is a number sentence you are going to write on the board and present to your chosen class. Write it down as you will refer to it throughout the presentation, but keep it to yourself for now. You will share it with your colleagues in a moment. Pause the presentation here and continue when everyone is ready. So, how did you go? If you're happy to, please raise your hand if your number sentence looks similar to the suggestions appearing on your screen now, as in some numbers and the chosen operation on the left-hand side of the equal sign, and an answer on the right-hand side. Can the people who raise their hand share a brief explanation of why they wrote their number sentence in this way? You only need 1 to 2 answers here. Continue with the presentation when you are ready. Now, raise your hand if you have something similar to these number sentences written down. If so, could you briefly share with your colleagues why you wrote your number sentence in this way? If there are no examples similar to these, discuss whether you think these are in fact appropriate examples at all. Continue with the presentation when you are ready. So why are we here? Basically, the purpose of this presentation is to challenge your current understanding of the equal sign, encourage you to rethink the way you teach it, and give you some suggestions on how to change the way your students interact with this very important symbol in mathematics. And you're probably wondering what more you could need to know about such a simple topic. Well, according to McMahon, it is not the concept that is the issue. It is the misconceptions held by most students that is the biggest problem we are facing. North et al. Support this and claim that these misconceptions are not only strong and widespread, but also long-lasting. Now, to understand the misconceptions that are often held by students around the equal sign, we must first look at how they define the equal sign and what it does. But to start, I would like you to look at the number sentence you wrote down. Use it to help you write a definition for your students around the equal sign, one that you could perhaps use with them in class. Pause the presentation here for a moment to share your ideas. What was similar about your definitions and what was different? So with your definitions in mind, let's have a look at what the research shows students actually think. The responses appearing on your screen now were given by students ranging from kindergarten through to year 9 when asked what the equal sign is and what it does. Take some time to think about these responses. Are they correct? Do you feel that they are accurate? Do you notice any misconceptions? Share your ideas with your colleagues and then continue the presentation when you are ready. So what is the actual definition? Well, according to McNeil et al., mathematical equivalence is the relation between two quantities that are equal and interchangeable. The symbol that shows this relationship is the equal sign. However, in most primary schools classrooms, it is often only represented as an arithmetic expression followed by its outcome. Therefore, reducing the equal sign to something that simply tells me where to write the answer. Now, the result is that children view the equal sign as an operator symbol, as in it tells them to simply calculate. It loses its rich relational properties and students are unable to understand its actual purpose and function in numeracy. Pause the presentation here and discuss for a moment what you think the impact of this misconception might be. Have you seen it in your classroom with your student and in what ways? Continue with the presentation when you have finished your discussion. Now, to truly understand how this impacts students, we're going to do a quick activity. It's something you might like to try with your students, obviously tweaking it to make it appropriate for the grade you teach. I'd like you to solve the problem on your screen. Share your answers and your process with your colleagues. To share your process, I'd like you to start with the solution is 12. I know this because, and explain what you did. For example, the solution is 12. I know this because I counted on from 8. Pause the presentation and share a few of your ideas. Now solve this problem and share your answers and process just like you did before. Continue with the presentation when you're ready. Finally, I'd like you to solve this problem and again share your answers and the process you use to solve it. Pause the presentation, share your ideas and continue on when you're ready. Now let's have a look at how students might answer these questions when they only have an operational view of the equal sign. Now firstly, they can do this question quite easily and as such appear to have a strong understanding of numbers and how to use them. 4 plus 8 equals 12. When we come to the second example, it shows that the students do not understand that they are being asked to balance the equation, that the equal sign is asking them to find something equivalent. So they answer in the only way they know how, which is to do the operation on the left-hand side, 4 plus 8, and record an answer on the right-hand side, 12. Now in this final question, students without a relational view of the equal sign are unable to make sense of the problem at all and therefore are unable to solve it. Now as you can see from the examples on the screen, when children view the equal sign as an operational symbol, meaning a symbol that simply tells them to find the answer or to calculate, they are unable to use it beyond this basic idea. The impact of this is twofold. Firstly, they see mathematics as a black and white subject. You can either get it right or get it wrong. You can do it or you can't. And secondly, and most importantly in relation to the equal symbol, they do not develop algebraic reasoning, which only supports their idea that maths is something they can't do, as when they get to the later years of schooling, they are unprepared and ill-equipped to take on the secondary school numeracy curriculum, particularly algebra. The research has shown that the impact of these misconceptions are profound and will follow students throughout their lives. Now, before we take a closer look at how we're going to fix this problem, I'd like you just to glance over the misconceptions we have discussed so far. Have a chat with your colleagues about them. Can you add to the list? Are there anything specific to your classroom that you've noticed with your students that relate to these misconceptions? Once you've done that, have a look at the impact these misconceptions have on students and discuss with the colleagues any further ideas you have or ways in which you think these misconceptions have impacted your students in your classroom. Continue when you are ready. So what should we do? McNeil et al. Explain that difficulties with mathematical equivalence are most apparent when students are asked to solve equations that have operations on both sides of the equal sign. These are known as mathematical equivalence problems. The issue is that they are rarely seen in the traditional K-8 curriculum. It is therefore vital that the relational properties of the equal sign are introduced, explored and developed in the early years of school and continue to be explored throughout primary school and beyond. Now we know what we need to do, let's have a look at how we're going to do it. I'll give you an overview of what it looks like each step of the way and then move into some explicit examples that may be appropriate for your classroom. It's important for you to notice that developing this relational understanding, though, happens over time across all stages and is not one segmented idea that is taught once and then set aside. Now, when we start teaching students to have a relational understanding of the equal sign in the early years, we focus on the mathematical language and the many different representations of equivalence through the idea of balance. Moving through kindergarten and into stage 1, students will start to develop the idea of equivalence and can start to represent it with concrete objects. It is important to note that we use concrete materials before numbers. Students need to see how many objects are on each side before we replace them with an abstract number. Otherwise, they will not understand that balance means having the same value, not necessarily the same thing on each side. From stage 1 through to stage 2 is about exposing students to many different examples of equivalence, from mathematical equivalence problems using the 4 operations to beginning to look at fractions, decimals and percentages, all of which involve the idea of equivalence. We continue to develop the language and we want to encourage students to look at patterns in numbers, make generalisations about numbers, and continue to develop strong number sense. It is imperative that students see numbers as flexible to truly grasp the purpose of the equal sign. Stage 3 and beyond, we start to look at algebraic reasoning and introducing those early concepts of algebra. By this point, students should have a solid understanding of the equal sign and equivalence, and therefore be able to successfully participate in the numeracy as the curriculum progresses. Let's take a closer look at some ideas. Starting at the preschool and kindergarten years, and well before we even introduce the equal symbol, we want to be introducing the students to the idea of equivalence through mathematical language and representation. On the screen is a couple of ideas of how you can do this. You can watch the suggested storybook or song by clicking on the links in the presentation or the comments below. Come back to the presentation when you are ready. Towards the end of kindergarten and throughout stage 1, we want to increase the understanding and language of equivalence. We do this by using concrete materials. For example, use the balancing scales and colour blocks or objects to show and spark discussions around making things balance. Giving students many opportunities to do this with a range of objects and in a variety of ways will help to develop the idea that equivalence means to balance things out. Students should also be recording their answers with pictures and through discussions. Things such as drawing scales and what they put on either side to make them balance allow students to see that equivalence generally involves finding two things that may be different in appearance but which have the same value. A great example of this is the Balancing Without Numbers lesson from the people at Resolve Education. Follow the link to have a quick look and return to the presentation when you are ready. Now, once students have a strong understanding of what balance means and have started to relate it to equivalence, as well as having good one-to-one correspondence and number identification skills, teachers can start to introduce the equal symbol and show how it performs the same way the scales do. It balances out quantities. Only once they have a good understanding of the purpose of the equal sign should teachers introduce numbers. A great starting point for this is to draw the equal sign on the floor or whiteboard and place counters or objects on either side. Count how many on each side and then replace that with the number that represents that quantity. This shows a clear connection to students between the concrete materials, the symbols, and the idea of equivalence. As they get better at this, you can start to introduce the idea of starting with two different quantities and finding out how many different ways you can make them equivalent. For example, adding 2 more shows us that 4 is equivalent to 2 plus 2. As students enter stage 2, move to stage 3 and beyond, they should already have a firm understanding of equivalence, the purpose of the equal sign, and how to use it. So we must start to extend their relational understanding of the equal sign. We do this through rich, open-ended tasks, such as this substitution game. To play, students are given a number sentence and then take turns changing the equation by substituting one number with an equivalent way to state that value. Pause the presentation here and have a go with a partner. Discuss how you could use this game in your class and how you could differentiate it where needed. For further instructions, click on the link. It is imperative that we continue to use the appropriate mathematical terms and language for the equal sign when using the 4 operations. Using is equivalent to instead of simply equals is important. Talking in this way helps to remove the idea that the equal symbol tells us to calculate. As students continue to deepen their understanding of the equal sign, it's also important to expose them to numeracy patterns, generalisations, and algebraic reasoning. This ensures that as they move through the primary numeracy curriculum into the secondary curriculum and beyond, they can easily notice and identify number patterns, have already developed a strong, flexible number sense, and be experienced users of algebra with the skills required to engage in it successfully. Follow the U-cubed links for examples of tasks that show this. A whole school approach is required to successfully change the way we teach students about the equal sign. Firstly, a whole school language focus so that all staff and students use the same terminology to describe equivalence. This is imperative to developing student understanding. Next, a clear sequence for teaching the equal sign so that teachers from each grade know what knowledge their students are coming into their class with and where to take them next. Access for all students to grade appropriate concrete materials is vital for successful teaching of this concept, as well as collaboration between staff when teaching the concept, in particular around students who are either taking longer to grasp the concept and need extra support, or students who are quick to understand and make connections and therefore need to be extended. And finally, continued professional development for staff on best teaching practice in numeracy will ensure continued growth and change towards building student success in this area. So there's been quite a lot to take in. Here's the important stuff that you need to remember. The equal sign should be taught as its own concept before it is introduced as a part of a number sentence or with the 4 operations. Students need to be exposed to numerous examples of equivalence through pictures, stories, and objects before it is introduced as a symbol. The language used to talk about and describe the equal sign is extremely important right from the start. It must be correct and must be purposely used to slowly connect the idea of equivalence to its symbol, the equal sign. And finally, students must understand the difference between the operational and relational views of the equal sign. This understanding will help them see their misconceptions and change their way of thinking. I'll leave you now with a task to complete and some time to discuss what you have learnt today with your colleagues. I'd like you to have a look at the number sentence you wrote at the start of this presentation. Firstly, how could you rewrite it to be a better example of equivalence to your current class setting? Then conduct a quick number talk with your colleagues using your revamped number sentence. Consider the terminology and language you are using or should be using. Finally, discuss what specialised content knowledge you will now use to conduct a successful lesson on equivalence and introducing the equal sign to your students. Please don't forget to take a copy of the handout as it has all the links to the activities suggested today and the reference list as a suggested further reading on this concept. Thank you.